Whenever we find a polar coordinates question, the first thing is to draw the approximate location for point A and point B. So we have a polar asset and then we have a starting point or region. We rotate 175 degree anti-clockwise. So to find A, we draw here, where the angle here is 175 degree and the distance traveled is 8, we get point A. Afterward, we try to draw another point. Pay attention to how many extra degree to rotate. 295 minus 175, we rotate extra 120 degree. So we rotate 120 degrees approximately like this. And then they have the same distance, 8. So it should be relatively the same. Approximately the same. So we have point B here now. In part A, they ask the perpendicular distance from O to AB. O is talking about this point. AB is talking a line connecting A and B directly. So this line is AB. We have to find the perpendicular distance. So we are measuring from this point to this line. Distance between point and a line is just draw the shortest path there. So this blue line is the distance that we need. Our target is to find out this. Furthermore, if we are going perpendicular to line AB, then we know that this is right angle. So now we have a very useful shape, which is the right angle triangle. We are concerning this triangle. This angle is 60 degree. So if I just draw this triangle, O to A to the intercept point, right angle, we have 8, we have this angle 60 degree. So we can get this distance by using a suitable trigonometric ratio. To this angle, this is adjacent. To this angle, this is hypotenuse. So we are going to write down cosine ratio. Cosine 60 degree is equal to D over 8. That means D is equal to 8 times of cosine 60 degree. Then we use calculator, or you remember the special angle is 1 over 2. So we get 4 cm here, 4 units here. That's the answer of part A. And then we have to write down the polar coordinate of point C, such that this is the constraint of C, such that O will be the center of rotational symmetry triangle ABC, which means that we have to search a point for point C so that it is rotational symmetric. You have to imagine how is a rotational symmetric triangle look like. So if you draw like this, isosceles triangle only, then it's not the order of rotational symmetry is just 1, so it do not fulfill our requirement. Then we think about more symmetric one, so we have equilateral triangle. So our target is to draw an equilateral triangle with O in the center. Now we have 1 over 1/3 of the triangle. We have to find another point. So you may extend this line, and then until the distance is 8. Then you can find an equilateral triangle if every angle is 120 here. So that's where is point C. You have to understand this requirement. If we have an equilateral triangle like this, then O is the center of rotational symmetry triangle ABC. If you realize that, then it's much easier. If you find out you want to know the angle here, how can we go to point C? It seems like we rotate 175 degree and then we rotate back 120 degree. Therefore, the coordinate of C, first same distance, also 8 from origin, and then the degree should be 175 minus 120, 55 degree.